my loves. Happy Star Wars Day! So excited. Oh, who am I going to share? Okay, wait. Bum, 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 ba-da, bum, ba-da. Dun, 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 da, da, da. Wait. Got it. I got double Darths. Woot woot. Artem and Dylan and Adriana. Which one? This one's my favorite that Adriana did. I love her Han Solo. Look, is he the coolest? Oh my gosh. You guys, you three did an amazing job. Did you watch the video? It's really kooky. It's really weird. For those of you who are not like up to speed with Star Wars, Kylo Ren is the son of Han Solo and Princess Leia, and he killed his dad. This is why. No, that was my reaction literally in the movie theater, screaming, no, that's not allowed. And I was not the only one who had that reaction. But it's Star Wars. Yay! May the fourth be with you. Okay, so exciting stuff here. Good morning. I don't know if I said that yet, but I'm so excited. Okay, let me. Okay, hold on. Here we go. Okay, today's lesson. Well, first there's the video, Scruffy Nerf Herd. Please don't forget about the Star Wars Zoom today at 12, where your t-shirts or your costumes, bring your lightsabers, all that kind of fun stuff. You cannot be in the meeting unless I have a message from a parent on Class Dojo that says you are allowed to be in there, because we're recording it. We don't normally record it, but we are recording it, and we're putting it on the AGA Facebook page, so I need your parents' permission for that. Okay, today we are multiplying fractions, and you've got some Mega Math for practice and IXL for practice, and news about science. So we were originally at 3 grades. We're moving down to 2. You guys are struggling with time, some of you, because I know a few of you, you got it. A couple of you, well, quite a few of you are struggling with time because the reading lessons might take a little longer, and then the math lessons. So I'm shortening those science lessons. So here's what's happening with those science grades. You will have 1 grade of those comprehension questions, okay? So 24 questions. We don't have to worry about doing the bonus. I would love for you to do the bonus. You'd have a great time with it. You earn coins when you do that. But my grade will just be the 24 regular questions. And something cool I've noticed is some of the newspapers share bonus content. So some of the newspapers we haven't even gone to yet, you've already got the bonus points for that because they share. Just something interesting that I found. And then the 2nd grade is going to be your choice of the crossword puzzle or the multiple choice test. Okay, now everything's getting graded as classwork. Okay, and it's a completion grade. If you completed the crossword, you get 100%. If you completed the test, you get 100%. Okay, so that's how that is. I put it that way because I know some of you really like that crossword puzzle, and some of you are having a really hard time with it. It's not recording. Here's what we found out. If you have anything incorrect, any tiny misspelling or the wrong word or anything like that, it will not record and tell me. You have to have 100% in order for me to get that little check mark. So I've noticed that's the problem. A couple of you guys are sending me screenshots, and I'm seeing, oh, look at that, you've got a misspelled word. That's why it's not recording for you. Okay, so either you have to pay really close attention for it to turn red, or just go ahead and do the multiple choice test, because even if you get it right or you get it wrong, it will let me know that you did that work. Okay. So that's different now for science. Math is still the same. The two teacher assigned lessons and your 50 minutes. And tomorrow is going to be interim reports. We're at the middle of the quarter. Those interim reports are going to be, I think, emailed home. And that means that you have probably about 12 hours. I don't know, about 12 hours to catch up. Some of you have not done any of my lessons in iReady. You need to get those done. Otherwise, we've got like a permanent record of you not doing anything for the last 4.5 weeks. So let's get some stuff going. Make sure that you're doing my teacher assigned lessons. And you can always go back and you can do the old lessons. And especially with Studies Weekly, go back and do the old lessons. I downloaded 45, no, I didn't, it was 90 reports. I downloaded all of your grade reports and I am sending them to you. If you have a score that's a D or an F, if you don't get an email from me today that has your scores, it's because you have an A, a B, or a C. I'm not going to flood your inboxes with all of this stuff because you're doing a good job. What I'm doing is I'm sending them to my students who are struggling. And I think if you had it in like black and white right here, this is what I'm missing, this is what I have zeros in, and then maybe you can like check off that list and go back and do those lessons. So today's Monday. You have 2 new math lessons. You have new Studies Weekly. Don't do them today if you're behind. Do some of the old ones first and then do those. Don't forget to do those this week though. You've got to get those done as well. But catch up, please. I have some of you who are missing every single lesson. Oh my goodness gracious, why? You're doing like 7 hours of iReady. It's fabulous, but not one of my lessons. Oh, okay. I'll be okay. Okay. And anything else? Yes, I've got something else. Let me show you. The students page of awesomeness. My internet is slow. Student page of awesomeness. Here we go. Okay. So I have some star students of the week. We have Gerard. Awesome. Gerard was missing a few assignments, but boom, 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 he caught up. Fabulous job. And Sean McKenzie, fabulous job. He's been doing an amazing job since we started this online teaching. And then Sebastian and Kareem. Oh my goodness, Kareem. Do you know that he did, I think it was like 6 hours of iReady Math in like one day to catch up. This kid is going places. He is ready for 6th grade. He is just working, and he is showing that he can do this, and he's getting himself ready for 6th grade. I've got goosebumps. Look, goosebumps. I'm so proud of you. Proud of all 4 of you. Amazing job. Last week, star students, you are now all stars. Okay, so you have joined the ranks of the all stars. Guys, if you want to be the star student of the week, then you need to make sure that you've got all your iReady done, the teacher assigned lessons, and 50 minutes, and get all of the Studies Weekly done as well, okay? Really important, guys. This is showing that you are responsible for yourself, for your grades, for your education. Going into 6th grade, no one is going to be hugging you, holding your hand, writing your name on top of your paper. Your teacher has no name on that paper, it goes right in the trash. So, you know, that's why I was really trying to train you, get you ready, do it right. Okay, do yourself proud. All right, my loves. I think that is everything. I think that's everything. Those are all of my notes for today. Let me go ahead and jump to Studies Weekly. Studies Weekly. Okay, so we're in our final week of space. We started with the solar system. My computer's lagging. Like really lagging. Let me go really slow. Okay, it looks like it's catching up, sort of. Okay, so we started with the solar system. And then we went on to the galaxy. And now we're at the universe. Do you see how we're getting bigger, bigger, bigger? Uh-oh. Studies Weekly. I don't know what's going on with this guy. Guys, please don't wait till the last minute. A lot of you are waiting until Friday at like 4 o'clock. And Studies Weekly was jam-packed full of like every student in the state trying to get their assignments done. Don't wait till the last minute. Get it done. Get it done beforehand. I don't know if we're going to load. We got it. Okay. Let's head over to science. I hear some birds chirping out my window. They're very loud. They're very happy. They're happy that it's Star Wars Day. My computer is so tired. Okay, come on. Ah, that looks promising. Scooch down. We are at the universe. Okay. So today we're going to talk all about stars. Speaking of stars, they're over here. Do you see the twin stars of Tatooine? And you see Luke Skywalker there. The twin stars of Tatooine. Twin stars are stars that are together because their gravity kind of keeps them together. They're twins. They're twin stars. Let me pull up the article all about stars. Scientists are continuing to make spectacular discoveries. We have telescopes that can see more stars at greater distances than ever. Hubble telescope. Here is some of what scientists currently know about things like distant stars, nebula, and galaxies. How hot is your star? Stars are really nothing more than giant spheres of burning gases. Scientists know that different kinds of gases burn at different temperatures. They also know that the color of a flame depends on how hot it is. Have you ever seen like a flame from like a birthday candle, and you'll see like the yellow flame and the orange is at top, and then as it gets lower, it's like blue, bright blue and white. That's the hottest part. Stars, especially when looked at through a powerful telescope, have colors of their own. By observing the color of a certain star, scientists can learn a lot about it. Red stars are the coolest. See, just like that birthday candle. And they're about 5,400 degrees Fahrenheit. That's way hotter than a birthday candle. Orange stars are a bit hotter. And yellow stars like our sun is close to about 10,000 degrees. Okay. So we've got the coolest being the red. Orange is getting hotter. Yellow stars like our sun, hotter still. White stars, 19,000, even hotter. And then blue stars are the hottest at more than 35,000 degrees Fahrenheit. That's more than 3 times the heat of our sun. Blue and white stars are young stars. You know what? That makes a lot of sense because when humans are young, they've got a lot more energy. And as we get older, we kind of like chill out a little bit. You know, we relax. We get tired. My goodness, we've been working so long. So it's kind of the same with stars. And blue and white stars are young stars, and they're generally pretty small as stars go. Just like us. As they get older, they cool and expand, like Miss Allison, to become yellow, orange, and red. Some old stars become huge, swollen fireballs called red giants. And they grow to more than 10 times the size of our sun. When our star, the sun, grows as old as some of those, it will possibly become so large that it will fill much of our solar system. So this is probably the most popular star in our galaxy, even though we don't think of it as a star. It's our sun, and this is a close-up picture of it. And you can see those solar flares coming off of the surface. Can you imagine what kind of sunburn you get being that close? I get sunburn at midnight. I can't, nope, not get any closer to the sun. Thank you very much. How bright is your star? If someone asks about the magnitude of a star, then they're asking about how bright it looks from the Earth. So there are three things that determine the star's magnitude: the heat of the star, how far it is from Earth, because remember, the further away the smaller things are, and then of course its size. For example, close, old stars might look brighter. So remember, if they're old, they're not very strong, right? They're kind of cooler and they don't give off enough heat, as much heat or as much light. But if they're close, they're going to look brighter than those super white, hot blue stars that are farther away. Twin stars, they're over here. Some stars, just like on Luke Skywalker's home planet of Tatooine in the movie Star Wars, the best movie ever, are found in pairs. And these are called binary stars, twin stars. In one scene, do you see it? My chair is squeaking as I move, okay. In one scene, Luke is looking at a sunset with two suns. There really are star systems like that, minus the humans, monsters, I wouldn't say monsters, and robots, of course. No evidence of that yet. Scientists can tell if a star is binary from studying the way that its light reaches Earth. If the light from a star wobbles in a certain way as it reaches the Earth's telescopes, it means that something big is pulling on the star. And that something big is the gravity from another star, or maybe even a large planet. Now look at this gorgeous picture. Nebula and interstellar medium. Most of space is a vacuum. That means it's just empty space with nothing there. But there are also many gases, dust, and particles floating around called interstellar medium. Among this floating around stuff are huge clouds of gas and dust called nebula. And though they may not look like it, those clouds contain the basic ingredients for building stars. The Horsehead Nebula and Crab Nebula are examples of nebula that we know about and have pictures of. Some nebula glow because of matter that is ionized and charged. And sometimes stars and nebula sort of decorate each other. For example, the Lagoon Nebula has clouds of glowing gas and shimmers beautiful colors in the light from nearby stars. Solar wind, which is energy from stars, whip through the nebula and make it glow even brighter. When a nebula shrinks because of gravity that builds up, it becomes a protostar. Proto is like before. Eventually, when there's enough gravity, the materials in the nebula combine and a star is born. Excellent movie. Also, sometimes you have stars that are actually moving towards each other, and at some point they're going to collide. And we have that as well with some galaxies. And galaxies, as you know, are huge clusters made up of billions of stars and other objects that float around like planets and moons and things like that. In the center of a galaxy is a core. Some galaxies, including our own Milky Way, are called spiral galaxies. Can you guess why they're called spiral galaxies? Because the stars near the outside spiral gracefully around the core. There are about 100 million stars in our galaxy. And if you look up at the sky on a clear night, you can see a large strip of many, many stars right down to the middle of the sky. You know, you can even look up and see other galaxies as well. That's really awesome. We can see the Andromeda Galaxy from the sky. And now, you know what, this works especially well if you're in the country, away from city lights and things like that. And if you look at that strip, you're looking at the center of the Milky Way. And scientists think that there are at least 100 billion galaxies in the universe, and that each one is made up of billions of stars. I mean, so that's just mind-boggling, huge. The Whirlpool galaxy is shaped a lot like our own Milky Way, and you can see the whirlpool coming out. That's pretty neat. Invisible stars. When a star becomes very old, it can run out of nuclear energy and stop radiating light altogether. Without that radiating force of energy, the star's core collapses. This results in a giant explosion called a supernova. Now, they're very rare, but occasionally scientists see one. A neutron star might result from a supernova. Okay, so we have a star, and it kind of runs out of energy, and it collapses, explodes into a supernova, and then we would get what's called a neutron star. Some neutron stars become black holes. Others might become what we call pulsars. And pulsars send energy out into space, but they do it in pulses. So they don't have enough energy to do it all at once, just kind of piece and piece in little bits. You have may felt your own pulse. That energy that pumps your blood through your veins comes in a steady rhythm, your heartbeat. Pulsars send out energy in much the same way. They sort of blink with energy. When a supernova explodes, it releases a huge amount of energy, and a star collapses. Then it throws off an expanding shell of gas, known as a supernova remnant, and it spreads out in all directions at very high speeds. Okay, we have 3 questions. Let's see how much you remember. Which galaxy is our solar system located in? Well, we know that one, right? The Milky Way. Do you remember the tale of the Milky Way well, lots of different cultures have tales of how the Milky Way started. One Native American culture says that the Milky Way began when a coyote, I don't remember exactly, I have to read it again. It's either a coyote or a dog, they found him eating their corn, and they chased him away, and he jumped into the sky. And as he jumped, he scattered the corn from his mouth, and that became the stars. Isn't that really neat? And then the one that we read from Africa was how a young girl put her hands into the fire of ashes and threw the ashes up into the sky to create the Milky Way. And there's a little bit more to that story. The story goes that there were men in her village that were out hunting, and it started getting late, it started getting dark, and she was worried they wouldn't find their way back. So she put the stars in the sky that made a path so they could find their way back. What's really interesting about this is people actually do use the stars to navigate. They can travel, and they can have those stars lead them back home. So we're going to learn a little bit more about that this week. Which of the following stars would have the greatest magnitude? Remember the magnitude? It means how close it is, how hot it is, and how big it is, right? So would it be a red large star that's 40,000 light years away? Or a blue small star that is 30,000 light years away? An orange large star that is 40,000 light years away? Or a white small star that is 10,000 light years away? I think this probably should be the red one, because this is challenging. Let me think about that. All right, so we've got 40,000, 40,000, 30, and 10,000. Okay, the red star is at 40, which is like in the middle. And then we've got an orange, which is stronger than the red. So cross out that red. So now we have, we're down to 3. Oh, it's getting easier. Okay. The orange star is 40,000 light years away. And then we've got a blue star, a blue small star that's closer. Well, wait, we know that blue means it's super bright, super strong, but it's small. It's closer though. But then the orange, it's not as bright, but it's bigger, and it's a little bit further away. And then we've got finally the white small star that's 10,000 light years away. I'm kind of thinking that's a long ways away. I'm thinking, So what do you think? Orange large, that's 40, or the blue small, that's 30? Let's go with the blue small. Incorrect. Oh man, it's got to be that orange one. What? Wait a minute. Is it the white? Wow. So that tells me, oh, I'm glad I got that one wrong. Okay, here's what this is telling me. I'm thinking. It's telling me that even though an orange star is closer, and even though a blue star is closer, look at that. The white star, that's the furthest away, has the most magnitude. So that tells me it's not necessarily the size. And it tells me it's not necessarily how close it is. I mean, those are important. But it looks to me like the most important is the intensity. So a white star, even though it's small, and even though it's 10,000 light years away, is going to be brighter. It's going to have more magnitude than the closer stars that are red, the closer star that's orange, or the closest star that's blue. I'm really glad I got this one wrong, because now I got to think about it, and I got to think, what's most important? It's going to be that color. It's going to be that intensity. Ooh, that was a good question. All right, the article states that when the sun grows as old, when 900 year olds, you know that one? When 900 years old you are? Yoda? No, you don't know that? Look it up. The article states that when the sun grows as old as the stars that have expanded, it may fill much of our solar system. What impact do you think this will have on Earth? That's a really good question. So right now we have life on Earth because we are at the perfect distance from the sun. And the sun is like the perfect amount of heat for us. If we were any closer, way too close. If we were any further, way too far, and life would cease to exist. So what would happen? Let's see. Would Earth's atmosphere adapt and not much will change? Will Earth move its axis location? Will the Earth become too hot to sustain life as it does now? Or will the sun's gravitational pull push all the planets out further away from its location? Well, wait, that doesn't make sense. Gravitational pull means you're pulling, not pushing. Well, that one, nope. I think the Earth's going to get too hot. Let's see. Let's go. Yes, we got that one right. Okay, let's go to the bonus sources. Bonus, come on, bonus. Okay, here we go. There are some really cool pictures here. And I really suggest do a search, go on NASA, find some stuff that's really interesting to you. Look at this. Oh, this is a dying star. Remember we talked about like that supernova? Look how beautiful. A dying star is spewing out massive amounts of hot gas and intense ultraviolet radiation. This is called a planetary nebula. And let's see that stellar wind that they were talking about. Look at that. So awesome. A picture of stellar winds that were created by this fast-moving star, and it's making ripples in the dust as it comes closer. You know what's really interesting? The fact that they call all of the pieces, like in the galaxy, the parts, like the dust and the little pieces that make up planets and stars and things, they call it medium. And it's interesting because that's what we call your materials in art, a medium. So like, are you using paint? Paint would be your medium. Are you using pens or pencils or chalk? That's your medium. But look at this. This looks like art to me. So it's kind of interesting that space has its own art medium. I think it's beautiful. These are absolutely gorgeous. And then we were talking about those constellations. So in the sky, you can find those constellations and you can actually use them to navigate and find your way back home. Before we had compasses, people used constellations in the stars to find their way. A constellation is a group of stars that make a shape in the sky. They don't make a shape. Humans look at it and they create amazing stories and they kind of say, yeah, that sort of looks like that shape. Have you ever done that? Like look at this at the clouds and say, oh, that looks like a goldfish. That looks like a bear. Yeah, it's the same thing, except with the clouds, they change constantly, right? By the time you say, look, 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 it changed. But the stars will stay the same. And people say, okay, that looks like a bear. So we're going to call that, the bear constellation, Ursa Major. So humans kind of made a map and they said, this is what we're going to call it. Here's a wonderful tale that goes along with it. Here's, a legend that goes along with that. And we're going to learn a little bit more about that and kind of do some fun stuff with it too. So they said this looks like a big bear. They're going to call it Big Bear. All right, my loves, here's what you're going to do today. Well, this week. This week, I need you to read all of these amazing articles. I need you to answer those questions at the end of the articles. And then you have your choice. You can either do the multiple choice test or you can do the crossword puzzle. Okay, remember the crossword puzzle will not record your answers unless it's 100% correct. And even then, sometimes I think we're just having problems with it. But if you've never had a problem with it and it works great for you, go for it. If it just deletes on you and you just, oh, it's driving you crazy, do the multiple choice test. No big deal. Okay, my loves. I will see you at 12 today. Synchronize our watches. And okay, bye. Dun 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 dun.